Hello, today I'm gonna review the new ChatGPT 01 Mini, which is apparently the new super strong coding AI. And we're gonna do this by asking it to optimize my graph render code in my Mario 64 mod. So this is my prompt: help me optimize my graph render code for my N64. N64 uses a MIPS R4300i. And number one, I think we want this data throughput. We want small code, few memory reads. CPU cycles is secondary. We're telling it we're using GCC OS, and we're explaining real quick that the graphic render system computes the matrix and orders the display lists. So next snippet will contain the code. So apparently this has like a reasoning module. It great blah 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 blah. Okay, I don't care about all this. What? All right, cool start. Let's give it the code snippet. This function computes the sine and cosine and returns them into separate float racks using the complex number extension. We use the appsf macro, which compiles to the apps.s instruction, and we use a cf macro, which compiles to elui/mtc1 instead of the lwc1 that GCC would usually compile. Can you optimize this ? That's a lot of text. Current overview, polynomial, yeah, I got that right. Yep, that's true. Doing a redundant operation. Remove the appsf macro. Let's remove the appsf operation. See what happens. I mean, if it's redundant, shouldn't GCC compile that out? It's one instruction less. If it works, it works. Well, that was horrendous advice. This is an interesting concept. Unfortunately, you're doing integer math on floating point registers, which will incur an MFC1 and MTC1 penalty. So this will be worse. I don't even need to test this. I'll just tell it. You are using integer math on float tracks. This will incur an MTC1 and MFC1 penalty, making this slower. Branches are also no issue because there is no branch prediction here, so don't worry about those. They are just one cycle. CF is already inlined. Yeah, I was wrong on everything. Cool. It didn't make a change. Alright, well, I'm just gonna assume it's perfect then. Let's do the next one. This function takes a float. This is a MTXF to MTX. This function takes a float 4x4 matrix and has to convert it to a 16 matrix that is 4x4x2, with the first 4x4 being the high bits and the later 4x4 being the low bits. We can assume the last 1x4 column can assume to always be 0, 0, 0, 1 in the float matrix, and should be output as that in the int matrix. Let's see. Do while is faster, so I hope it can do that. The reason do while is faster is because it can assume that you will do the loop at least once, so it doesn't have to do the branch at the beginning, it can just do it at the end. Will just put this in, compile it, see what happens. 2A68? One instruction more. It failed. It made it worse by one instruction. Does it work though? It works. I mean, it works. It's worse, but it works. All right, next code. I don't want to waste tokens for nothing, so a function like this we probably didn't need to put in there. Same with this. This feels like maybe something can be done. All right. So this function converts a segmented address into a lem address. Try to optimize this. Minimize casting. Guess the other even once and we use the casted value. Well, it's gonna do that in a single return statement, and that won't make a difference. Register allocation, inline assembly version. Okay, inline assembly version. I like the sound of that. Let's see the C version first. Same. Inline assembly version. All right. Bro is speaking my language. Operand 3 out of range. Alright, before we actually go through with figuring out how to make this inline assembly work, let's actually think about that. Wait, I don't have a separate version of this. Let's just look at this. Okay, SRL looks fine. Andy T1%1. That's the A0 register, I guess. So that's just A and 0x bunch of Fs. SLL by 2 makes sense because we want to convert to the pointer index. T2, T0, T %2. What the fuck is %2? Is this just like segment table? Okay, yeah, so it adds to the value of segment table. This will be a Louis, and no, actually it should get the segment table before, and it will be a GP. So this should just be add GP something. Actually, it might not. I think this will actually be an extra instruction because it has to add to GP to get as a segment table to pass into this. And then we're reading from 0 here, which is a problem because you want to read from %high to and then %low to from T2 here. So I think this will be one extra instruction. T3, T1. T1 is good. Ori, yeah, that's fine. It's WT4. Result is T4. Yes, but this actually makes me think of something else. Why do we even need this? What if we just change the segment table so that every time we read from the segment table here, I'll just go back to my code, I prefer this. Yeah, I'm gonna do this after this video here, because this is not actually related to what I'm doing. Just a good idea I had just now. Alright, next we have toggle AA on DL. This would be a nice one to optimize. This would be very nice if we could. So let's ask it. What it did here is rubbish, I'm pretty sure. Current function. Segment address, true. Reduce pointer casting. Casting doesn't cost anything. Cache frequently access value, load once per loop iteration, reuse them. What? You want to load them before? That's just taking on even more memory throughput for no reason. But okay, yes, this is what I think it would have done, which is why I didn't give it those, because I don't want that to be done. GCC will do that by itself. Remove break after return to save OP code space. It's compiled to the same thing, right? Yes. Language compile optimization, use static inlines, suggesting whether a function is appropriate. You can't, it's a recursive function. If you inline a recursive function, you get an infinite function. Right, let's see what the difference is. OP code is W0 and FF. That's not what it is. The OP code is the first bit. You just gave me the last bit. This would not work. Okay, yeah, you made no differences. You made no changes except you broke the code. Cool. Toggle AA on the ASM. Why do you wanna just assembly code this? Dude, I swear. This is something new programmers say. They're like, yeah, assembly is more optimized than C, and then every time you look at someone's assembly, it's just terrible. It's just worse than the C compiler would do. Like, a compiler is smarter than, I would say, 90% of programmers. And even, compilers sometimes make dumb mistakes, but like make so many smart things as well that you would never think about. So it's like, yeah, don't do this unless you're like actually completely correct. Either way, let's move on to the next function. This function computes an S16 matrix that represents a Billboard matrix that looks at the camera. Does it have translation? Position, yes. And scale? Yeah, okay. It handles translation and scale as well as set the rotation. Alright, let's see what it does. Translation component settings, yes, correct. Correct. I mean, it understands what I'm talking about at least, right? That has to be very impressive. Nope. Unrolling the loops gives you more code. I told you we want small code. What is all this shit? It just keeps this around from the previous questions. Oh boy. What? No, that's not how it works. It's gonna set desc 12 and desc 28, and desc 12 is not 4 bytes aligned. Actually, it is 4 bytes aligned, but desc 13 is not 4 bytes aligned. So this will just crash the game. And we can't unroll this. No! US 32 writes won't work. They don't just randomly split up 16 bytes further down in memory. Also, some of those writes are not 4 bytes aligned and will crash the game. Also, your loop unrolls cause bigger code, which results in more data throughput and is slower. This has been a bad experience so far. Okay, now we're splitting into high and low, which is exactly how I've been doing it. It kind of removed the plus 16, which I thought aided readability, but you know, readability is like, who cares? It is optimized. Dude, it's just being like, it's being such a bitch to me. You know, when you're trying to put away the dishes and your mom tells you put away the dishes and you're like, I don't want to do it anymore. That's how I feel with what this guy's telling me to do. Alright, let's try what it wrote here. Probably the exact same code. It's 2 instructions slower. You can tell it's 2 less from how this increased by 8. Okay, well, maybe I can do something with this. I mean, this feels like there's some smart loops to be rolled up. I feel like this could be done. This could definitely be done in a loop. Oh, yes. This is something for it to optimize. You can definitely do this in a loop. I'm just gonna tell it to do this in a loop for me if it doesn't think about that itself. Alright. Let's see what this is. Always inline? No! That is way bigger. It's mem copying the Billboard matrix? Did it even understand that this is a different function? Okay, this guy just completely shit the bed. No, this is a completely separate function. Forget about the Billboard matrices and optimize my rotation and translation matrix. Inlined the function that was already inlined. And it said dest33 to 1.f, even though our mtxf to mtx assumes 33 to be 1. which means this is an unnecessary write. More bug mitigation. Okay, you know what? It actually understood that the N60 was the more bug. Oh wait, never mind. I put that in the comment. It knew that this function existed though. That's kind of cool. Oh, it changed the order of operations. Okay, this is actually something it couldn't possibly know. But if I change the order of operations, like it suggests here, the mole bug gets worse, I think, right? We had 2A6C. We do this. We saw 2A6C. Okay, never mind. It does make a difference. Cool. Well, I guess this very marginally improved readability. Definitely not what I want though. I think one optimization we can do is to roll the loop at the start of the function up and instead do 3 loop iterations to get SX, SY, SC, and so on. Let's see that. I actually think it might not be faster. Let's see what this does. I might have done it correctly, maybe not. 2A6C? 2A90? Oh, right. Okay. This is more, because this is an inline function that returns sine and cosine and f0 and f2. But if we actually have this be like a physical thing, like a real thing that's not just a register, but like store them on stack, we're gonna have a lot of stack reads and stack stores attached to this. So that's actually bigger code. I guess that's the issue. So rolling up the loop is a bad idea for memory throughput and cycle count. Interesting. I wonder if we can optimize this one here. So this function computes the matrix for a shadow, optimize it, and I should say position and alignment with the floor. Optimize it. So far, I will say there wasn't really any improvement from the AI. I saw 2 potential improvements myself while going over this again, which is something that happens basically every time I look at this code. But yeah. I know there's a lot of AI haters out there. I'm very neutral about AI. I think it has its uses. So I don't want to just shit on it and like pretend to be part of the AI hater club to get people to like me. Fuck you. But so far it has actually not been very good. I mean, it's kind of impressive it can do this at all. I feel like most programmers I would talk to wouldn't be able to like understand this as well as I do and have like a conversation with me about it. But also most programmers I talk to wouldn't just make shit up. So there's pros and cons. Wait, that's a crazy idea. Wait a second. That's a crazy idea. I like that. That might just work. Although, to actually make these scale indices work, we're gonna have to probably put them into a separate array in memory. Invalid use of keyword restrict. Okay, well, let's just do it without the restrict then, I guess. 2A64, 2A44. 8 instructions down, dude. Yes, that's nice. Alright, let's understand what the full difference here is. Optimization highlights. Loop consolidation. From nested loops to single loop. Raise a nested for loop with a single loop iterating over a pre-computed array of indices. Yes. That's nice. Eliminate the function called overhead. By declaring helper functions are always inline, they are inlined. Okay, well, wait, what? Well, they were already inline, so it doesn't matter. Is this inline? No, but it doesn't need to be, does it? Actually, this one does worse if it's inline, doesn't it? Let me just check that real quick. Always inline. 2A44, 2A48. That's 1 instruction more. Honestly, that 1 instruction more might actually just be cheaper. So I will keep this inline. Fuck it. use a restrict keyword. The restrict keyword is very good, but it used it wrong, I think. I think if I do it like F32 to A30 still, okay. Let me just make sure this still works. So the restrict keyword, also very good idea. It just handled it wrong, I guess. Let me actually step on one of these here. Yeah, it works perfectly. Cool, cool, cool. That's a big improvement. Holy shit. Okay, cool. We can probably do F30 star restrict then, and maybe get another optimization going. I probably have to do this. Well, that will be wrong. This will be wrong, but we can get it to be right with no extra cost. 2A10, 2A30. Okay, well, it's still 2A30. So I guess it does not matter. But just because it's the same and it has to restrict keywords, so there's no chance in the future I will look at this and be like, why doesn't this use the restrict keyword? I will keep it this way. Yeah, the shadow still works. That's good. That's a big optimization. That's like, what, almost 20 instructions. Wow. Very positively surprised by that. Cool. Alright, so this function, this next function renders texture rectangle points on the screen and has to compute the screen coordinates and stuff. This looks like it's all the same, and I'm sure it posted the final version up top. GeoProcess master list. This is the render particle stuff, yes. Definitely possible that there's an optimization here, but I don't have the energy right now to deal with that. Okay, I think this has gone on for long enough, so clearly it's capable of finding some stuff, which is cool. You have to be very expert at what you're doing to stop it from doing nonsense though. It has some nice creativity, but like, you have to know better than it, so you have to be very confident in your skill to actually be able to use this without screwing yourself over, I think. That's gonna be my review. I hope you like this. Bye bye. So I thought we were done, but I actually had to undo this because the optimization ChatGPT 01 figured out here actually crashed on N64 because it calculated the indices wrong, and as soon as I fixed the calculation here, it was no longer faster. So that sucks. We're gonna have to revert this and keep going from where we left off, which is here. Maybe it can find an optimization. I mean, it was still useful to talk to it. It gave me a few good ideas to restrict. The inlines were good, although that wasn't really something ChatGPT thought of, but oh well. I'm gonna ask it to do this function next. This function appends all the master display lists by layer to the display list heads, which makes everything render. Try to optimize it. Maybe it finds something. You never know. It did not understand the assignment. Optimized render all coins, but I wanted to move on to this function. That's frustrating. Spend all the time doing something useless. I don't know why it doesn't understand when I want to move on to the next function. I thought I was pretty clear about the fact that I wanted to move on. Do I need to maybe open a new chat? What's the answer? You thought for 95 seconds and didn't even give me an answer? What the fuck? For all the news that are being made, like, oh, this is gonna change everything, this is dangerous, it's jailbreaking itself. It's not doing a very good job. Why is there all this header bullshit? I don't want any of this. What the fuck? It doesn't understand that the current particle... Okay, well, maybe I should have given it this to define. Yeah, I should have let it know that. It couldn't have known what the define is. You misunderstood or... Oh shit. Per particle does it's define for this. Please fix that code. Also, maybe I can tell it to omit all the header bullshit. Omit all the useless stuff about the function you are trying to. Okay, I'm just gonna stop it here. Dude, you didn't say anything? Again? It started so well. I mean, I'll give it that. It couldn't have known that core particle is defined for particle array I. That's a very confusing way I coded this. So I can't blame it for that, but the bugs with it not answering and like it giving all this useless stuff all the time. Like, what is this shit again? Alright, let's see what changes it made here. I was like, I kept the registers? Yes. Okay, techniques for minutes by loading them into temporary variables if necessary. You know what? I'm just gonna take this whole thing, paste it in, see if it's any better. Instead of reading all this, that will save me some time. Because if it's the exact same compilation, then we should be fine. Also, this cannot be an inline function. Why does it just assume that it's fine to make this an inline function? The reason this can be an inline function is that this is linked from a jump table. So if you make this an inline function, it will no longer work. Invalid storage class for function Neki. Oh. 2820 29DC. Okay, that saved a lot of things, which makes me think that it broke everything. If not, then this is an insane optimization. I don't see anything broken. What? Okay, now I have to understand what it actually did here, because that would be an insane improvement. Else we get a temp matrix. It defines the temp matrix on the stack instead of using the temp matrix I have in memory. Does this make a difference? I want to see if the change comes from that. Because if it comes from that, then it's likely not a good change. Because having one temp matrix in memory that I'm always editing, so I can just do the floating point math on that, it's a little bit of an optimization. Wait, it even added this shit here. I don't want that. Still 290C, cool. I guess it can never be null. We also don't want this. Now it's 2A6C. Okay, so somehow doing the temp matrix and the loop unroll gets us way better performance? How does that make sense? There's no way it knew that. Absolutely 0% chance. That's the entire optimization, that these are like two separate things now. I just can't wrap my head around why. I wonder if maybe because this is the same variable name as something else in memory, it's compiling to something wrong. What if I use temp matrix 2? Still 294. Also, why is there MTXF to MTX before this? That doesn't make any sense, does it? Shouldn't this happen afterwards? This should happen afterwards. This should be like this. Oh, now it's 2A7. Okay, I got it. So what happened here is, because temp matrix 2 is now a stack variable, GCC knows it can discard the state of temp matrix 2 after MTXF to MTX. But while it was a memory variable for, it didn't know it can discard this state. Meaning, while the code was like this, it was allowed to just delete everything. This is what GCC saw. And now we're back to 29E4. That's why this looked like an optimization, because it unoptimized something in a way that made GCC think it can just discard this now. So that was a bug in my code. And the bug is also in ChatGPT's code. So now the bug is fixed. And now everything ChatGPT did is way worse. Cool. I mean, in a way, it found the bug in my code. Or, well, I found the bug in my code because ChatGPT tried to fix my code. I guess that makes it a very valuable rubber ducky. And I mean, I found some improvements while talking to it. That's also very nice. So far, across the entire video, we saved 12 assembly instructions, if I remember correctly, which is pretty nice. I didn't think I was so close to perfection that ChatGPT wouldn't find a single thing. Man, I generally thought AI was gonna be like great and helpful, but this video is just gonna be fuel for the AI haters. Why did you know that? Sorry, please answer. Maybe my architecture is too niche, maybe my function's too optimized, maybe it's just supposed to work with terrible programmers, maybe the small performance difference doesn't matter, maybe it's calibrated to make readable code and not well-running code, because that's kind of like all the code that exists, right? People care about readability a lot more than about performance, typically. And so I would imagine that's the code it's trained on, so it just fucks my performance to... Actually, no, it doesn't increase readability, it unrolled my fucking loop. Even though I told it explicitly not to do that. Alright, let's see what we got. Certainly, I will answer your question. Dude, I told it to admit all that. Code? Compute code? Yeah? I don't hate it. I think compute code is decent. Okay, I'll just remove the compute code. I don't like it anymore. Don't have the time to figure out why that just happened. Alright. Moving on to the next function, because it can't find anything here. I doubt there's an improvement here. Oh, maybe there's. Let's tell it. Great job. Maybe it needs a bit of motivation. Let's move on to the next function. See if we can optimize this one. It just made the function more verbose. This is a cool thing you can do where you compare to 0 instead of comparing to iteration count. It saves one instruction. I don't think it's possible to find an improvement here. Let's see if it can do this. This next function here computes a camera matrix. Try to optimize this. I bet it's going to inline normalize mad raw. Optimized function. Yep. I knew it. It also wants me to not do this. See if that's better. 2A1C. Oh, it's the same size. Honestly? Okay, fine. That honestly is an optimization. I'm like 99% confident 3 entries is all we need, but... Cool. That optimization was not what we want. Because, it caused that thing to just not work. Cool. So it broke my function. What else do we have? I will just... Dude, it unrolled everything again. Are you fucking kidding me? A54, that's way worse. I don't know why it won't listen to me. I just give up on everything that's rolled. Clearly, it cannot do those. Is there anything else that might be of merit in here? Yeah, I just unrolled all the loops. Alright. Fun. I'll copy it with the comments. Do not unroll the loops. We care about data throughput only, and unrolled loops equals bigger code equals more data throughput. Let's just move on. Can you optimize this function? What the fuck? This is gonna be way worse. Alright, 2A1C, we are going up to 2A4C. Cool. Maybe I can do something with this. I feel like there's some smart optimizations that can be done here. Good job. You are doing great. Can you optimize this one next? I don't know, man. Maybe it does better when you praise it. I wrote the loop again! Ah! Okay, this is honestly, this is an interesting idea. This might work. So it took all these and replaced, only those two. And then it took this and replaced it with this. This should cache the value on stack, although I think it was already cached on stack before. Yeah, this is not compiling at all. 2A1C, 2A14. Okay, that is an optimization. If it still works, if I didn't make a stupid mistake somewhere. What's the easiest way to check translation rotation? If we go to the WinCab level, we can check it. Because Mari's WinCab uses translation rotation. Actually, Mari's body uses it too, I'm pretty sure. If that makes the game run better, I will give it credit for finding a 2-cycle optimization in process translation rotation. Yep, it did. Well, it might be even more than 2 cycles. Definitely an optimization. Very, very cool. That's a free cycle improvement or free instruction improvement. 12 bytes of memory traffic down by ChatGPT. Yeah, it can't improve this. This is version 17 of like a 6-line function. Look at this shit. Look at what we had to do. This function is used in animations. Can you optimize it? Sure. To be fair, I had to discard like 95% of what ChatGPT said so far. But that 5%, see, I always say, when you argue with someone, you assume you're already like 90% right, and maybe they are like 80% right or something. But if you combine your 95% right, or 90% right, with the 80% right, maybe they have like 80% of the knowledge you're missing. They probably won't, but maybe they have like 1% of the knowledge you're missing. And now you're like 91 or 96% right. And that's amazing. So always listen to people and like evaluate the ideas, even if they are actual fucking idiots, because maybe what they're saying is kind of useful. Alright, 2A10, still 2A10, cool. No difference. You might think this should be rolled up, but this actually is a function that is used so much that unrolling this one is better, because it does save a few cycles. Well, let's see if we can optimize this one. Good job. Let's see if we can optimize the next function. This one computes rotation matrices for animated actors. I will just copy this, see if it's any better, and then move on. Again, it inlined this. You can't inline this. It's called from a jump table. A bool? Bool? Come on, man. 2A70. Okay, it made this way worse. Cool. Yeah, so my overall review of this is it can be very frustrating to work with. It does make a lot of mistakes and doesn't really listen to you, and there are some bugs in ChatGPT itself. But actually, it's not that bad. Like, it found improvements, which is amazing. For a code that's already this optimized, to find even more improvements, that's honestly impressive. I wouldn't... Well, actually, if I had a new programmer on this project and have them look over it, I would expect them to maybe find a few improvements. But they would have to be a really good programmer for that. To actually, like, find anything, to even understand what I'm talking about. So yeah, I would say ChatGPT is like as valuable as like a mid-tier programmer. I think that's fair to say. To have like, you know, to be in a meeting with. Obviously, having a full mid-tier programmer on your team would be a lot more valuable because you could make them do all the work and they would get a lot more done. Here you need to supervise it the whole time, otherwise it's gonna make everything worse. But yeah, that's my review. Bye!